All right, so for this one, we want to find the inverse. And the first thing we're going to do is I like to scratch off f of x and set it equal to y. Remember, y is just a placeholder for f of x. And your first step when you find the inverse, you want to switch the x and the y variables. So we have 1/3 log, I'm going to put y minus 7 plus 2 is equal to x. And your goal here is you want to get this log isolated. So you want to get it by itself. So you have to be careful with your order of operations here. So before we can get rid of this 1/3, we're going to need to subtract 2 from both sides of the equation. So we're left with 1/3 log, and then y minus 7 in parentheses is equal to x minus 2. Now we can go ahead and multiply both sides of the equation by 3. And you got to be careful over on the right side that you either put parentheses around the x minus 2, or you can go ahead and distribute 3 into both of those terms. But either way, you need to make sure that the 3 gets distributed. So I'm going to go ahead and distribute it and write it as 3x minus 6. Okay, so now here's the part where you kind of have to understand how logarithms work. In order to get to this y that's on the inside of the logarithm, you're going to have to get rid of the log, and you can't divide it away. What you're going to have to do is take the base of that logarithm, and since it's the common log, the base is 10. You're going to take that 10, and it's going to become the base of your exponential, and the 3x minus 6 becomes the exponent of that exponential. And then it's going to equal this y minus 7. And now that that y is out of the logarithm, you can work on this 7. So you need to get that 7 over to the other side, so I'm simply going to add it over. And so your exponential function is 10 to the 3x minus 6 plus 7 is equal to y. Now the instructions here say use your graphing calculator to confirm that the functions are inverses. So I'm going to show you how to do that here on a TI-84. So the first thing I'm going to do is I'm just going to go ahead and graph the original function. So I'm going to clear out what I have in there, and I'm going to type in 1/3 log x minus 7 and plus 2. Now I know you don't have to graph this, like in terms of you don't have to graph on paper, and you can't really see much of that graph anyways, but I'm going to go ahead and go to the table. So I just hit the second and then the table button. And what I'm going to look for is just a single nice point, if it exists. In this case, we see the point 8, 2. So since 8, 2 is on the original function, the point 2, 8, so the inverse of that, should be on the inverse function. So, because this one, if you graph the inverse function, based on how that graph looks, I think it's going to be hard to tell visually whether or not the graphs are inverses. So if you go ahead and, I'm going to go ahead and clear that out, and then type in our inverse, which is 10 raised to the 3x minus 6, arrow over and hit plus 7, and go ahead and graph. So that's our inverse, what the graph looks like. I'm going to go into the table, so second table, and oh, look, there it is, the point 2, 8. So that's a pretty good confirmation, I would say, to confirm that your functions are inverses without actually doing composition and all of the technical math that you have to do. So just a quick check in your calculator for one of those points, and hopefully that should help you feel better about your final answer.